Welcome to lecture number 16. So, we have started discussing on the various statistical models of machine learning. In the last lecture, I gave you some introduction to machine learning, right. So, let us carry forward that, and basic aspect of our discussion will center around how to find correlation between structure properties and processing. But it will not be clear at the beginning how machine learning can bring out this correlation. Later on, we will see how we can correlate with these aspects. So, we discussed that machine learning and deep learning are part of the bigger picture of artificial intelligence, and we are seeing more application of artificial intelligence in today's world, in our daily life. Most of you probably using mobile phones, and there are many AI tools are inbuilt in the mobile phones. To be very specific, when you type something on the chat box, many times computer or mobile phone can understand what is that you are going to write. So, it provides you lot of text automatically. That is nothing but a chatbot, and chatbot is a real application of AI. So, we are using AI every day, but you have to understand ability of AI is very limited at this moment. It can only mimic some human making mind decisions and problem solving capability, but still we are far behind as far as the human brain capability is concerned. So, AI can allow the machines to understand and achieve specific goals for specific task. Remember these words. We want to achieve specific performance for very specific task. Performance has to be linked with task. We cannot talk about any performance in this world, and that is basically the major aspects of machine learning. So, machine learning is a process, although we know that is a process or a computer process or whatever, by which machine can learn from experience, that is from existing data. And when it learns from experience, it learns to do a specific task, and when it does a specific task, it is giving you some performance. So, if it does a specific task, let us say T, that is what we discussed in the last lecture, specific task T with some performance P, and this it does after an experience E learned from existing data. So, that is what it is, from existing data it learns, that is his experience. Just like us, we also learn from existing experiences. Many times you are having the first time experience, but there you learn many things. But soon as you experience something more and more, your learning capability increases. So, machine learning exactly does same thing, it learns from data. But the question is why, you must be thinking why data, why not something else? It can learn from text also. So, anything it can learn, but right now limit ourselves to data, because we are very familiar to data. Those of you who are doing experiments, they know that we produce a lot of data in terms of properties of material, data in terms of images, data in terms of spectroscopic analysis. So, data are very common, and we feed the data to the machine learning model, or rather I would say we put the data as input for the machine learning model, and data, the machine learning algorithm learns from the data, that is what is called experience, and it learns with specific tasks with certain performance. Now, once it applies this learning for the same task, its performance must improve, then only we call it a machine learning. If performance remains same or performance decreases, that means machine learning model has not been applied properly. That is something which you have to understand. Now, machine learning uses structured data. Structure means processed data, right? It cannot use any data you want to feed it. So, therefore, pre-processing of data is a underlying thing when you talk about machine learning. Structured data means is basically pre-processed data. But on the other hand, deep learning, which we will talk later part of this course, it does not require any structured data. It can use any unstructured data in the form of text, images, spectroscopy images, anything. This is very important for material scientists, because many of our images taken from scanning electron microscope or any other devices are basically in the form of very simple images. But we know images contains lot of data, but they are not structured data. Hence, how to utilize this unstructured data for artificial intelligence? That is the domain of deep learning. We will talk about it in quite detailed manner. First, let us learn what are the machine learning and what are the things we can do. So, I hope this is very clear to you. One last time I would like to tell you that any machine learning process is what? It depends on an experience which is automatically learned by the computer or machines using existing data. But this learning is basically for a specific task, and when it learns, it is learning specific tasks with a specific performance. Very simple. If I have x, y data, for every x there is a y. So, what does it mean? X is an independent variable, y is a dependent variable. So, this independent dependent variable combination provides you certain task with performance. So, computer also learns, machine also learn automatically that aspect. After learning, it has to deliver. And it has to deliver in such a way the same task when it is performed, but its performance must improve. Then only it is a successful machine learning process. In a very logical or simple manner, I try to explain to you. So, now what is the difference between machine learning and the conventional approach? Okay, I have been talking about you for quite some time that in traditional approach or conventional approach, you use a trial and error type of approach. So, as we do some experiments, we get some results, but we learn from the experiments. Experiment is giving you some results, it may be a failed experiment, but we do not throw it out. In material science, we do not throw it out. We take a sample, do some heat treatment, and heat treatment does not give our desired properties or desired microstructure. Does it mean that the experiment is useless? No. That experiment is a failure experiment, but it gives you an idea that under the processing conditions, experiment did not succeed. You need to change the processing conditions. That is what it is. So, it gives you a data point that experimental condition of temperature, time, whatever you use, heating rate, cooling rate, it did not succeed. So, you must not use that. So, that is basically a mistake, or that is an error in the process. Again you try some other parameters, and once you try many times you get a success. That is why it is called a trial and error experiments. Trial and error, remember this. These two words are very important, because that is what is led to many discoveries in the various fields of science. Trial and error. You try something, you may succeed, may not succeed. If you succeed, it is good, your luck has given you much better ability to achieve success. Some people may not be as lucky as you, then it is an error or mistake we consider. But it is not a mistake, it is basically a failure. So, now this was what is a traditional or conventional approach, but this was good. Why? Why? Because this led to discovery of many new things, whether you talk about high temperature superconductors, talk about quasi-crystal, talk about metallic glasses, or many important materials. These are all discovered from failure. I know many Nobel laureates in our field actually. I do not have a very personal interaction with them. They wanted to achieve something else, did some experiment with some other target, but finally experiment failed, but they discovered new aspects. So, that is the critical aspects of trial and error. So, when you do trial and error, you have a chance of discovering something new. That is what I am talking about it. The chance of getting Nobel Prize is much higher when you are trying something new. But in the early part of the last century, 20th century, quantum mechanics and molecular mechanics came into picture. But quantum mechanics was just a theoretical tool in those days, because computers were not available. I am talking about 1900 to 1930s. So, computers were not available. So, therefore, quantum mechanics was just a theoretical tool. Many of you know that Planck, Einstein and many others, Dirac, they have used quantum mechanics to explain various kinds of aspects. But quantum mechanics allow us to go to molecular level, atomic level. And then molecular mechanics is what? Molecular mechanics is nothing but considering each atom as a particle and apply Newton's laws of motion, right? You can do that. So, if we use Newton's laws of motion, second law of motion, let us say, where force is equal to mass into acceleration, you can easily find out from this equation what will be trajectory of that particle, right. So, in a system with consisting of many atoms, we know the forces acting between them, because we know the energy and we can calculate the forces. So, therefore, and we also know the mass, therefore, we can calculate the acceleration. And now, knowing the acceleration, you can find out a particle which is at time t equal to 0 at some location, where it will be after a certain time. That is what is called molecular mechanics. It talks about dynamics. That is why it is called molecular dynamics or MD simulations, many of you heard. These aspects came into picture, but these are not simulation in those days. 1920s, 1930s, 1940s, computers were not available, and if it is not available, they are rudimentary level of computers, so nothing can be done. So these techniques were known, but nothing could be done. But then after the explosion of computers, after the high power computing came in 1980s, high throughput scanning came into picture. High throughput scanning means if I want to achieve some properties of a material, or I want to synthesize a material with certain properties, how can I do screening so that I can reduce the number of experiments? That is what is called high throughput scanning. Many times you do experiment also to achieve properties of large number of samples. Let us talk about nano indentation. In nano indentation you apply a very small load of the order of millinewtons or even sometime less than that, and that load is applied to indenter, and then you indent on a material, on a particular grain or particular phase or particular boundary, and find out the mechanical properties of that. That is called nano-mechanical devices, and these devices allow us to probe the whole sample in a very fast way. I can measure properties of the sample in a, let us say, in couple of hours or maybe 6 hours, 5 hours time. So that is what is called high throughput scanning. There I can measure properties of large number of grains or even boundaries very easily. So that came into picture, and that has provided a huge change in the contrast to trial and error experiments. So finally, 1900s, a later part of 1990s or maybe beginning of 2005 or so, what is came as machine learning methods. That is what we discussed, because at the time computers are very powerful. We have many powerful computers available with speed as well as memory, high memories. So we can handle data, a lot of data, and we can do calculations. That is why the machine learning method came, and now we are 2024. So almost 15 years have gone to this field to come up with this level. That is why we are learning this method. That is the historical approach or the difference between conventional approach and the machine learning. So we already discussed about what is machine learning. So let us focus on the bottom two pictures. You see standard approach and the machine learning approach. In standard approach, what you do? You write a handwritten program, right? That is what you do with the handwritten program, and then do this solution, right? And this handwritten program can actually lead to a formula or equation many times. Thus does not use any data. But on the other hand, machine learning is a statistical methods that enables a computer to learn from data without explicitly programming it. Remember this. It uses data and produces a program to perform a certain task. So what is that? As you see here in this picture on the right side, you see here we have to use certain algorithms. Okay, that's we will talk about it today's class itself, and this algorithm can allow us to analyze the data, find correlation or find relationship between the different sets of data, and that can be done in a very systematic manner. That is what is the machine learning does, and it can be used for various aspects. Let us say first and foremost thing is image recognitions. Many of you must be traveling in airports using DigiYatra, something known as this DigiYatra, right? So DigiYatra actually has a capability to scan your image and detect you. So image recognition is very important. This is widely used even by the police or many other agencies in the world to find out a particular person. Many of you must have heard that best way of having identity is to scan the retina of a human eye, and that is very unique even compared to our fingerprints. So fingerprints also are images. So if you want to use, if you want to buy a new mobile phone SIM cards, you have to use Aadhaar as your main aspects, and there they will sometime they take your images, match the images of your fingers from the fingers with whatever existing database they have to detect you are the same person who is basically taking this, buy this SIM card. So that is very widely used technique as a machine learning technique. But remember, fingerprinting was discovered long back, maybe more than 100 years back, but in those days computers are not available. Then another important thing is used in machine learning, many people must be using is stock prediction in the stock markets. So what happens in stock markets is basically the stocks actually purchased or sold. There is a market driven forces. But can we predict that market driven forces, how the stock will vary? Well, this is possible to do that because it generates a lot of data. During this stock market business, a lot of data are generated, and we can use the data and feed a machine learning model to do that. Third important aspects is what is called as the medical diagnostics. As you understand, medical diagnostic uses a lot of images, CT scan, MRI, all kinds of things. This is MRI image of your brain, you can see there. It contains a lot of data. It's massive amount of data it contains. And now we can actually use the data to diagnosis of certain kind of diseases. And to be specific, doctors use machine learning more than we. And we don't know actually, that's what is the problem is, because they are using for quite some time, much earlier than us. And this is something which a lot of things can be learned from them, how they use it, what are the techniques they use it, but that's not a part of this course. But since I was reading a lot of literature, I came to know that the way they use, different techniques they use are much advanced than we engineers use. But other than that, one can use weather prediction. Remember, weather is also a very unpredictable. Very difficult to predict weather. Remember that, although you may get some probability of predictions, but many times it may not match. Sometime it will say it will going to rain, but you will see there is no rain on that day, because it depends on so many factors, and that's why weather modeling is so difficult. And it's a global phenomenon, it's not a local phenomenon. Weather here can be affected by the weather in somewhere in Brazil or somewhere in Argentina, right? So data analytics is very important weather prediction model, and this is what is widely used by the weather scientists. Now we also have robotics, right? And you know that robots are part and parcel of our life now, although we are not using it in our personal life, but after some time robots will do most of the operations. Experiments will be done by robots. You don't need human. We can program even robots, and robots actually operations of robots depends on this machine learning and deep learning things, how fast they can learn human activities and many more. I don't want to talk about it that, but we can use also machine learning in material science like alloy design. But material science are relatively slow learners. This field came after a lot of time. It is not very fast. And so therefore, consider machine learning when handwritten rules and equations are very complex. We cannot find a very simple equations between variables. Then it is possible, like facial recognitions. Face do vary from one to others. Although I know there are 7 people in this world who will have the same face like I have, but it is not possible to detect easily. Facial recognition, speech recognitions, pattern recognitions do not follow in specific equations, they can be easily done. Or you can have a task whose rules are changing very fast, like fraud detection, from transaction. Many of you may have faced the monetary fraud, right? And there are a lot of anomaly in terms of monetary fraud, because humans are very intelligent. They can commit this fraud in very different ways. So how to find, how to track those kind of frauds, like in ATM card frauds or many other things. So that's why this machine learning can be easily applied. Or you can have situation in nature of data are changing fast, and a program needs to adapt that, like automated trading in case of stock markets, energy driven forecasting or shopping predictions. Very difficult to do that, right? Alloy design falls on the same thing. Alloy design exactly is same that nature of data changes, and the program, a computer machine learning program needs to adopt that kind of data. That's what is the problem of that. So how the machine learning data actually, the workflow goes on? Very simple. We are talking about that, right? Very, very simple. First thing, you need a lot of data, and that means either you need to have collect the data or generate data. Remember, data can be also generated by using theoretical model, or maybe you can do experiments. So data generation or data collection is the first step, or baby step rather I would say. After that, you have to do a lot of data engineering. What does it mean? You mean you have to process the data, you have to put it in proper format so the machine can learn easily, and then this engineered data or whatever you have got it will be fed to a machine learning model. We will talk about some of the models today, and then models will be trained. That is what is your experience is. Data are fed to a model, machine will learn the correlation of the data. That is what is called experience for a specific task with some performance, right? Once it is learned nicely and it can do the jobs nicely, then you know that your model is working. After that you have to validate the model. That means, that's working means what? Working means in a computer, it is not working in the real experiments or real life situations. That is what you need to do, model validation, okay, this step. Model needs to be validated using some experiments, certain kind of a real life experience or whatever it is. Then only you can apply or deploy this model, remember this. So, what is training? Training is nothing but you iterate till you find the best model, correct. You have to keep on doing the things, that means you have to keep on getting experience till you know that is the best model. So, as you see here, the pre-processed data will have mean, standard deviation, or even PCA, we will talk about that later on, the what is data analysis, or it can be also supervised learning like classification problem or learn or some other problems, and finally it fits the data in a very nice manner, okay. That is what is called your learning. So, once you learn, then you have to integrate the trained model with the applications, and that is what you need to have test data. Initial data was trained data or load data, this is called training data, okay. Many people call it training data. This data will have correlation between x and y. X is a free variable, y is an independent variable. And then once you do that, then you have to test it. The test data, using test data you have to do that. And then again you can, after testing you can predict whatever you want to do. That is what is your final objective, to predict the behavior of the things whichever you want to predict. So, in a very formal definition is basically nothing but what? Improvising and learning. That is what is machine learning. Some specific task with some experience and evaluate in terms of certain performance. Am I clear? That is what it is. So, the AMN model actually is like this. You have experience, you have some work experience, so with for certain task, certain performance, you apply that. That is what it is. I am telling you again and again different ways so that you understand. You do not get confused, because there are in the internet there are a lot of information which are not correct. So, that is why you should read books and try to understand these aspects. And exactly same thing here, I do not want to go to again the steps of machine learning, this is the same what we discussed. So, now what are types of learning possible? What kind of learnings we can do? So, as you know, when you are a kid, you learn from your parents, right? That is what is called supervised learning. That is the easiest way to understand. It is called supervised learning, and it develops a predictive model based on both input and output data. Remember, it has structured data with input and output that easily can be learned by supervising. Let me give a simple example. When I gave you this example last class also, when a kid learns how to walk, so what does the kid does? Basically, it initially start crawling, then after some time he or she will hold something and start standing up. After standing, he or she will try to put one foot right or left foot ahead and the left again move, right. But in the process they fail, or sometimes they will fall on the floor, right, many cases. That is what is called learning. But what happened? Then one of the parents will come, hold the hand and make him show how to walk. That is exactly what is supervised learning is. So, it develops a predictive model based on the input and output, remember that. So, here output is what? To learn the walking on the floor, that is what your output, right, and input is your way of taking the step, that is what is input. You have to take the right step, right way, so that you do not fall, that is what is your purpose. So, you need to have both input and output data and correlated data, remember. If it is completely uncorrelated, you cannot do supervised learning. And what are the categories of algorithm? Classification is one problem, regression another. Regression we will discuss in the next lecture. And in unsupervised learning, you have groups of interest, based on only input, okay. You must be thinking how it can do that. Well, you have only input data, there is no output data. What you can do is you can do cluster the data, okay. Certain kind of data can be coming as a one cluster, certain other kind of data come other cluster, right. There are many other things we will discuss one by one when you talk about these models. So, that is how actually supervised and unsupervised learning is important. And in material science we use more supervised learning, the alloy design other things, but there are cases of unsupervised learning also. So, we will talk about this supervised and unsupervised learning in the next lecture. Since I was giving an introduction, I thought of talking you about all these aspects, and we will carry forward that and we will show you how regression is one of the easiest statistical model to understand. I will show you that. So, let us carry forward in the next part of the lecture.